Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iman Irfan bin Muhammad Yusuf from class Z4 EM1104M, and today I want to share my results of experiment 2 of fluid mechanics, which is the stability of floating bodies. Objectives. First is to investigate how the floating characteristics of a pontoon is affected as it is filled with weight and tilt. Second is to study the metacentric height of a pontoon and its stability. So objectives, these two objectives is why we decided to start the experiment, so that we can know more about floating characteristics, which is in general called as buoyancy. Now let's go on about the introduction to this experiment. So the fluid properties is designed to demonstrate and show how the properties of fluids and its behavior is like under hydrostatic conditions. So what I mean by hydrostatic conditions is when the object or the unit is submerged either partially or fully in water. So application of necessary laws such as the Pascal and Archimedes law is important to determine properties such as density, viscosity, and surface tension of fluid. So anything that is that has connection to fluid, like density, uh, like like we give you an example. Density is let's take water and oil, and we try to combine or submerge each other, and we could see the result, which oil is denser than water is denser than oil. So water will be beneath oil, and we could clearly see that those two will not mix. So by understanding this basic mechanics and properties of fluid, a wide range of application of hydrostatic principles will be put under study. So when we go through with this experiment, we could understand that the stability of bodies could be in great use to replicate into notions of buoyancy, flow rotation, and stability of floating bodies. Okay, now let's go and talk about the apparatus used in this experiment. So this is what we basically call the floating pontoon, where it can be used as a medium to determine the metacenter, and it could also be used to investigate the stability of floating bodies. Okay, now let's go on in detail. First, we have the mast up here. We also have the sliding mast just beneath the mast. Then we have the linear scale, which is used to locate between two or more prominent marks on the scale. Next, we have the adjustable mast, where we can set the mass of this entire pontoon. We can make it heavier, or we could also make it lighter. We have the transverse shaft. We also have the pontoon, the plumb line, and the pendulum. Okay, so what is pontoon? Basically, is a simulation of a flat bottom boat. Okay, so let's talk about procedure now. So what is procedure? Procedure is a set of instructions to uh, complete an assessment, or to complete an experiment in a smooth flow way. Okay, maybe this is too long to introduce, so I came up with a better way of seeing the procedure is by using pictures. So step one is we have to open the transverse and adjust the mast. Okay, here we could see in detail. Second is to reassemble the adjustable mass to the pontoon. So we set the mass we want to experiment with, and stick it to the reassemble it to the pontoon. Third is we have to measure the whole set of pontoon body. Fourth is uh, next is to fill the sink with water and float the pontoon. Fifth step is we have to check the zero datum between plumb line and the scale. Okay? So you have to set that it happens at zero scale. Next is we move the adjustable mass to the right of center in 10 millimeter increments. So this is the parameter that we set up from 10 all until 80, right? 80 millimeter. Then next uh, we have to repeat the movement of the mass from the center, sorry, to the left side. Next uh, we have to repeat step 6 to 8 using a different height, which is 50 millimeters and also 100 millimeters. Next is we have to record all the reading, right? And then we have to record the data obtained into a table which comprises of two tables, which is the first to get the angle of displacement, and the metacentric table, metacentric height table. Right, and then step 10 is finally when the water in the sink can be discharged by using V16 valve. So next is the safety measures in lab. So during workshop practices, we always have to be responsible to protect our own safety. Okay? Some of the examples we have to remember that we should never run in the workshop. Workshop is filled uh, with machines, with sharp objects, with dangerous machinery. So running is always a bad idea, right? Next, we also have to wear proper attire, wear gloves, wear closed-toe shoes, so that we are not endangered to injure ourselves due to stepping on sharp objects like nails, right? So, and then we have to make sure that the machine we are using is clean right after we finish with the experiment. Okay? And there are actually more safety measures, but we have to stay to the basics. Next is the calculations of angle of displacement for 0 millimeter height. So in this experiment, there's three measured, it's three changed variable, which is we have the displacement of 0 millimeter height, 50 millimeter height, and 100 millimeters height. So this is an example of calculation of for the angle of displacement, right? Where theta is equals to b over a, right? So theta inverse is equal to b over a. So like an example I'll show you is like look at calculation number 3, where b as in the displacement is 34, parameter is 30 millimeters, and the way to calculate it is tangent inverse 34 times 34 divided by 330. So we have the final angle of 5.88 degrees, right? This is for the 50 millimeter height. Also using the same equation. For 100 millimeter height, we also is This is the way of calculating metacentric height calculations, where GM is equals to MAW times B divided by MP times sine theta. So let's look at example number 1 here, where parameters is 10 millimeters, displacement is 15, and degree is 2.6 degrees. So we have, it will be 0.2192 times 15 divided by 1.988 times sine 2.6 degrees. So we are left with the metacentric height of 36.46 millimeters. This is how I calculate the metacentric height for 100 millimeter height. And this is the proof and sample of calculation. Right here is when I use the equation tan theta is equals to B over A to calculate the angle of displacement for 15 millimeters displacement. So there I got the answer 2.6 degrees. And now I'm trying to calculate the metacentric height using MAW times B over MP over times sine theta. I just fill in the blanks here with the values and ended up with the answer of 36.46 millimeters. Now I'm trying to calculate the second moment inertia I, which is equals to LD cube times 10 to the power of negative 12 over 12. I got the value there, 1.5309 times 10 to the power of negative 4. And now I'm trying to calculate the Vm, which is I over B divided by V. Now this is my way of presentation of my way to present the data recordings in two tables. Right. First, we could see the experimental results. This on the left side is the parameter in millimeters, and there's three readings to take note, which is 0 millimeter height, 50 millimeter height, and 100 millimeters height. Okay. So in this experiment, we are only looking at the values of the right hand side of the measurements, and this is its metacentric table, right? Now to the plotting of graph process. So this is how I came up with the graph. So I just insert the value into the columns and rows. This is displacement of 0 millimeter height, its angle, displacement of 50 millimeter height and its angle, and lastly the displacement of 100 millimeters height and also its angle. So I just fill in the columns with the values that is obtained together with the angle of its displacement. So this could take a while. So so I took like around 15 to 30 minutes of plotting to come up with the graph itself, the graph of results of data. Sorry. So I use the line graph here, as you can see. I just key in the important notes, important things like title, axis title, and try to come up with a cleaner graph. Okay, and to guarantee that this is mine, I wrote down my name there, Muhammad Irfan bin Muhammad Yusuf, with my matrix ID, right? So this is the close-up of the graph, my name there, and the graph here, graph of results, where on the y-axis we have the angle in degree, and on the x-axis is the displacement in millimeters. So these are the recommendations on how to get more accurate results. First is I recommend increasing the weight of the plumb bob with proper care to not affect the results of the experiment. I also would recommend to take time in executing the methodology so that it would maximize the experiment's potential. Third is to read the scale carefully since it is in particular really small. And fourth is that we have to verify the analytical balance is well calibrated so that we do not come up with wrong values. I think that should be all. Thank you for lending me your ears and time. Assalamualaikum warahmatullahi wabarakatuh.